Alright, what's going on, everybody? This video we're going to look at summation notation. So let's go ahead and get started. It shouldn't be a long video. So we've got definition of summation notation. It says the sum of the first n terms of a sequence is represented by, this is the sum from I equals 1 to n of a sub I. And that just means we've got A1 plus A2 plus A3 all the way to A sub n, where I is called the index of the summation, n is the upper limit of the summation, and 1, this 1 right here, that's the lower limit of the summation. So let's work some examples, and then we'll look at some properties of sums also. All right, so the first example, it says find each sum, and we've got 3 examples here. So this first one we have the sum from I equals 1 to 5 of 3i. So this is just equal to 3 times 1, okay? We're starting at 1 and we're going to 5. And then plus 3 times 2. See, we're going to plug 1 in for I, then the 2, and then 3, and then 4, and then 5. And that's all it is. See, we're going from 1 to 5, so we plug in the 1, the 2, the 3, the 4, and the 5 in for I right here. All right. And then once you calculate that, you end up with 45 as an answer. All right, let's look at the next one. All right, so here we have the sum k equals 3 to 6. It doesn't necessarily have to be the letter I. Okay, in some of them you'll see the letter N. All right, and this problem it's k. So k is equal from 3 to 6 of 1 plus k squared. So what do you think we're going to plug in to this one? Well, we're going to plug in the 3 for k, then a 4, then a 5, and then a 6. So this is 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. And then we calculate that, and that gives us 90 as an answer. All right, so the next problem, summation I equals 0 to 8. So what do you think we're going to plug in here? Well, we're going to plug in a 0, 1, 2, 3, 4, 5, 6, 7, and then an 8. And so that's going to be 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial plus 1 over 7 factorial plus 1 over 8 factorial. All right, now, I don't know, some of you may know what factorial means, some of you may not know what factorial means. All right, so by definition, 0 factorial is 1. 1 factorial is 1. Now, let's look at these. So let's just look at the 5. So 5 factorial is just equal to 5 times 4 times 3 times 2 times 1. If we had 8 factorial, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, it's just whatever number it is here, you just go from that number all the way down to 1, multiplying them. And yeah, I mean, you don't want to punch all that in your calculator, 8 times 7 times 6, and so on. In your calculator, there is a factorial button, and I don't know where it is on your calculator because I don't know what kind of calculator you have. You just have to look for that exclamation mark, that factorial symbol, and just, hit it in your calculator and then punch all this into your calculator, and you end up with 2.71828. And there's your answer. All right, so now let's look at some properties of sums. So we have the sum from I equals 1 to n of c, where c is a constant. It's just c times n. C times whatever number you're going to. Okay, that's how you figure out that. This one, summation I equals 1 to n, c times a sub I is equal to c times this sum, and c is a constant. So what this property is saying is that you can take this constant here and you can pull it outside the summation. All right, you can't pull the a sub I out. All right, but any constant term you can pull out. And then the sum I equals 1 to n a sub I plus or minus b sub I, this works for addition and subtraction, is you can split them up and find the sum of each one individually. All right. All right, so let's look at definition of a series. It says, consider the infinite sequence a1, a2, a3, all the way to a sub I, and then it just keeps going to infinity. Okay, you've got an infinite number of terms. The sum of the first n terms of the sequence is called a finite series, or the nth partial sum of the sequence, and is denoted by a1 plus a2 plus a3 all the way to a sub n is the sum I equals 1 to n of a sub I. That's a finite series. All right. And then the sum of all the terms of the infinite sequence is called an infinite series, and it is denoted by a1 plus a2 plus a3 plus a sub I, and then it just keeps going to infinity. And that is the sum I equals 1 to infinity of a sub I. So let's look at a couple examples. So it says for the series, the sum I equals 1 to infinity of 3 over 10 raised to the I, it says find the third partial sum and then the sum. So the third partial sum, that's going to go to what? That's going to go from I equals 1 to 3. That's the third partial of the sum. See, if you remember from up here, let's see where, there it is. See, the sum of the first n terms is called the nth partial sum. So we're looking for the third. So that's going to go to 3. And then they want us to find the sum, and that would be this one down here, where I goes from 1 to infinity. So let's look at part A first. All right, so that's going to be the sum I equals 1 to 3 of 3 over 10 to the I. And that's going to be 3 over 10 to the first plus 3 over 10 squared plus 3 over 10 cubed. And that is equal to 0.3 plus 0.03 plus 0.003, which is equal to 0.333. All right, now let's look at part B. So this is the sum I equals 1 to infinity of 3 over 10 to the I. All right, so let's go. We got to go from 1 to infinity. So that's going to be 3 over 10 to the first plus 3 over 10 squared plus 3 over 10 cubed plus 3 over 10 to the fourth plus 3 over 10 to the 5th. Now, obviously, we would keep going plus 3 over 10 to the 6th, but there's no way we're going to write all these terms out. So, we can just continue it on with the plus and then the 3 dots. And so just calculating like the first 5 terms, that's going to be 0.3, that's 3 over 10 to the first, plus 3 over 10 squared is 0.03, and then plus 0.003, and then plus 0.0003, and then plus 0.00003, plus, and then it just continues on. And, and you can see the pattern that we're picking up. So if we went 10 to the 6th, that would be 0.000003. Okay, so each term is just adding a 0 and just pushing that 3 back a decimal place. So this is equal to point, and the 3's would keep repeating. Okay, and we know this is 1/3. So that would be that sum there. All right. And yeah, this was a short video, short lesson. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all later.